the base frame completed, I've gone ahead and saved that assembly. I'm going to start the creation of the shaft assembly. In the motion folder, I'm going to select the bearing flat. There will be two of these, but the workflow is the same for both, so I'll show you the first one. I'm going to be using eye mates again. We can see the location of the eye mates on the C channel. Let's rotate the bearing flat around so it's approximately in the correct position. Having done that, I can then snap onto the eye mates and place it in the correct position. There we go. Normally I would move them away, but there are so few eye mates here, it's pretty easy, I think, to get the correct one. And that completes the location of that bearing flat. To hold the bearing flat against the C channel, I need to go and get a pop rivet. So in the structure folder, a couple of bearing pop rivets. Again, we'll be using eye mates to locate these against the frame and through the bearing flat. We'll move those around so they're closer to the location. And using the same workflow we've been using, capture that eye mate, hold down the Alt key. Be careful with this one. There are two eye mates, one on the other side of the frame. It will be incorrectly placed if you selected that one. And again, pop that one into place. So now that bearing flat is held in position by the two bearing pop rivets. Next phase is to place the shaft. Now in this case I've created a custom shaft. It was created from the 3-inch shaft and it's 1.5 inches long. We'll place that in the assembly. We don't need eye mates in this case, we have circular edges, so I can go to the constraint command, insert, and select those circular edges. Flip the solution and key in a value for the offset, which is going to be negative 0.625 inches. I can change this later on if when I put the shaft collar on or put the motor on the other side that it's incorrect. So to complete this, I'm going to get two shaft collars. The workflow for these is a little different on each side, so I'll show you how to do both. Let's start with the one at the front. Again, we have circular edges, so we can use the insert constraint. Be careful when you have chamfers, you want to make sure you get the correct edge, not the inside edge, but the outside edge. Apply that. Now when we rotate the shaft, you'll notice that it's rotating, but the shaft collar is not. The easiest way to fix that is to apply an angle constraint. Select the top of the set screw, the shaft, select your solution, and finish that process. So now when I rotate the shaft, it worked correctly. It will be very similar on the other side, except I don't have circular edges to work with, so I'm going to use a slightly different method of constraining. I do have center lines to work with, so we'll use the center line of the shaft collar, and then of the bearing flat. Click OK, just drag that away so we can put the second constraint on, which will be a mate constraint. I could rotate it around, but using the Select Other tool, I can select that face quite easily. Click on OK, and again the same issue. If I rotate the shaft, that shaft collar is not attached correctly or constrained correctly. So I'm going to put an angle constraint to fix that. And that will work correctly. Rotating the shaft, you can see that both shaft collars are working. You just see it through there. And again, you can see that working. So anytime you do apply something like that, think of that angle constraint, and you'll be doing that on the other side.